Hi, hello dear students. Welcome to Karnataka SLC online. So in the last class we have seen some of the important questions. Okay. So we have done some 4 important MCQ questions and I have also given introduction part. Okay. So in this class we'll see, okay, we'll try to understand some more important questions. Okay. So fifth question, see. If a and b are zeros of the polynomial 2x square plus 5x plus 1, then value of alpha plus beta plus alpha into beta is, okay, you need to get the value of alpha plus beta and alpha into beta. So you need to understand the relation between sum of zeros and its coefficients. Okay, so we try to express sum of zeros in terms of sum of zeros with the help of coefficients. Okay, so sum of zeros, how you find how you find sum of zeros? Okay, so sum of zeros, okay, so represent with zeros means alpha and beta, sum of zeros means alpha plus beta. Okay, so you can get by minus b by a, okay, minus as it is. Now you need to just identify what is a, b, c. A is coefficient of x square, b is coefficient of x, and c is a constant. So here b means coefficient of x, which is 5. Okay, minus as it is a b value 5 divided by a value coefficient of x square 2. Okay, so sum of zeros is minus 5 by 2. Okay, so you need to know sum of zeros can be find with the help of its coefficients. Similarly, product of zeros, why product? Because alpha into beta, so we also need to find a product of zeros. Okay, product of zeros, it is alpha into beta. Okay, no need to put any multiplication sign, it is understood, it is alpha into beta. So what is the relation with the product of zeros with the coefficients? It is c by a. Okay, c by a. C value you can see constant, which is 1, and a value coefficient of a square x square, which is 2, 1 by 2. Okay, so student needs to understand the relation. Okay, student needs to understand the relation as sum of zeros is equal to minus b by a, and the product of zeros is equal to c by a. Okay, even you can write this as, okay, minus b means you can write a coefficient of, okay, x divided by a means coefficient, okay, of x square, correct? Okay, and this for product of zeros, even you can write c means it is a constant, c means constant, okay, constant, divided by a means again a coefficient, okay, of x square. Okay, this way also you can write. Now we need to find this value. Okay, alpha plus beta plus alpha into beta. So we will write alpha plus beta. Okay, I'll write in one bracket plus alpha into beta. Okay, so alpha plus beta we have got as minus 5 by 2. Okay, plus alpha into beta we have got to 1 by 2, and they are like fractions, denominators are same, numerators can be added. Minus 5 plus 1 you will get minus 4 divided by 2, so the final answer is minus 2. So you can see option A is correct, minus 2. Okay, so you need to understand the relation between coefficients and zeros. Okay, next one. Sixth one, if alpha beta be the zeros of the polynomial, okay, zeros of the polynomial 2x square plus 5x plus k, such that alpha square plus beta square plus alpha into beta equal to 21 by 4, then k you need to find. K value find madam. Again simple, namagen gottada alpha plus beta can be expressed with the help of coefficients, and also product of zeros also expressed with the help of coefficients. So we try to make a relation. Okay, we try to express sum of zeros and a product of zeros with the help of coefficients. Okay, see here alpha into beta you will get from the equation as c by a, and next we need to have a alpha plus beta. But do we have here alpha plus beta? We don't have. Okay, so first we try to express alpha square plus beta square in terms of alpha plus beta. Okay, so we'll try to understand alpha square plus beta square. Okay, so this I can write as, okay, so here we will write first, algebraic entity which makes use of alpha square plus beta square. It is actually even alpha minus a minus b whole square and a plus b whole square. Both uses as a square plus b square. But we want alpha plus beta means we want a square plus a plus b whole square. Okay. So what I'll do, I'll write alpha plus beta. Suppose if I write alpha plus beta whole square, it is alpha square plus beta square plus 2 alpha beta. Correct? So now in this place, alpha square beta square, alpha square plus beta square, in this place shall I write alpha plus beta whole square minus 2 alpha. So in this place I'll write alpha plus beta whole square minus 2 minus 2 alpha into beta. Yes, now I have expressed this in terms of alpha plus beta and alpha into beta. This thing I can find. Now so we will use what is given. Now so alpha square plus beta square plus alpha beta equal to 21 by 4. Now this one, so I'll call it as equation 1. So equation 1 we will use here. In this place shall I write this one, alpha plus beta whole square minus 2 alpha beta plus this alpha beta as it is, which is equal to 21 by 4. We write reason using 1. Using 1. So we have used 1 here. Now sum of zeros we'll get as minus b by a. Minus b means minus 5 by a means it is 2. We can find these values separately also. Minus 2 alpha beta plus 1 alpha beta will be minus alpha beta. So this we will put in the next step. So square it 25 by 4. Minus square will be plus only, minus alpha into beta nothing but c by a, c value k, c by a value means it is a 2, which is equal to 21 by 4. I need k value. When I need k value, k sign should be positive, so it is negative means I will shift k term to the right side. So when I shift k term right side, right side fraction I'll take to left side. So it is 25 by 4 minus 21 by 4 equal to, yes, the minus becomes a plus. Like fraction, we'll get 4 by 4. 25 minus 21 is 4. 4 by 4 equal to k by 2. So once therefore cross multiply. K 1 into 2, you will get k as a 2, k value 2. So the option again is A. So if they give sum of zeros and product of zeros, you can make use of coefficients directly. If they are not given, first you need to convert the given zeros in terms of a sum of zeros and a product of zeros. It is not sum of zeros, it is sum of squares of zeros, which is different from a sum of zeros. So this I have expressed as a sum of zeros and a product of zeros. Fine. Next one. If seventh one, if alpha beta are zeros of p of x, function of x, then the value of alpha inverse plus beta inverse. Now we will rewrite. So alpha to the power minus 1 plus beta to the power minus 1 is same as, shall I write 1 by alpha plus 1 by beta. Then with the cross multiplication you will get beta plus alpha with the cross multiplication divided by alpha into beta. And even you can take LCM, or with the cross multiplication you will get this result. Now this beta plus alpha is same as alpha plus beta. Commutative property of addition. Now now we have got sum of zeros and product of zeros, that we will get from the coefficients. So I'll write now. So alpha inverse plus beta inverse is equal to sum of zeros, it is minus, okay, b by a, and product of zeros, it is c by a. Correct? Now minus as it is. B value, you can say b value is minus 1 na? So minus 1, okay, divided by a value. Okay, instead of that, what we'll do, we will cancel, no problem. Okay, so you can cancel a and a, so you'll get minus b by c, minus as it is. Now b value, it is minus 1, okay, and c value, it is 2. So minus into minus plus 1 by 2. Okay, so the value of this is going to be 1 by 2. It is option C. It is option C. Okay, so you can observe the trend that given zeros should be expressed always in terms of sum of zeros and product of zeros. In the previous question also we have done same questions. Okay, next. 8th one, the zeros of the quadratic polynomial, okay, x square plus 88x plus 112 are, okay, so it is with respect to the sign. Okay, you need to understand what sign you will get for this given polynomial. You can see all the three, okay, a value, b value, c, all three are actually positive. In that case, what sign you will get for the zeros, that you need to find. So we know the family of polynomials, okay, polynomials, the polynomials, okay, standard form, okay, what is the standard form? Okay, it is k, okay, of x square minus, okay, alpha plus beta, okay, x plus alpha into beta, which is equal to 0. Correct? For an quadratic polynomial. Now the given polynomial, let me take k value 1, okay, k value 1. So now this is x square, okay, and I have to write that in terms of this formula, in terms of the same form. So plus 88, I'll write minus of minus 88x, okay, and plus 112. Correct? So I can say, after rewriting as per the standard form, I can say sum of zeros is equal to minus 88. Correct? This is very important. And then product of zeros is equal to 112. So we can call this 1 and 2. Now we can observe. So some common sense also you need to make use. Alpha and beta product 112 means what are the possibilities of signs alpha and beta can have. Okay, see, if I want to get plus 112 after multiplication, it means only two possibilities. Either both should be minus minus, minus into minus plus, or both should be plus and plus. Okay, we will see for alpha plus beta secondly. First, okay, firstly we will see for the product. So when you get plus 112 means either both should be negative or both should be positive. So you can eliminate option C and D. The answer is between A and B only. Now again, if I consider both positive, yes, both zeros positive, then multiplication will give positive. Okay, but if I add both, will I get plus 88? No, I'm getting actually it is minus 88, but with the plus and plus I should get a plus only, na? So here I have minus 88, so there is a mismatch. It means the both zeros must have a minus. So if both zeros, if you multiply, you will get plus 112. If both zeros, if you add, you will get a minus 88, because this is zero, the sum of zeros. Okay, so you can say by observing or by observation, by observation from 1 and 2, okay, alpha and beta should be negative. Okay, so this should be negative, both should be negative. It is option B. Okay, yes, next one. Yes, 9th one, if alpha and beta are zeros of a quadratic polynomial such that sum of zeros given and a difference of zeros also given, then the family of quadratic polynomials having alpha, beta as it's a zeros, okay, is given by. Fine. So with the help of sum of zeros and the product of zeros, you can express the zeros in terms of a quadratic polynomial, because here it is x square, the highest degree is 2, means it is a quadratic polynomial. Okay, so sum of zeros it is given. Okay, sum of zeros is given, sum of zeros is given, okay, 12, it is fine. What about the product of zeros? We need product of zeros, but here it is given difference, so we'll try to express difference again in terms of product. Okay, so it is given alpha minus beta equal to 6. Okay, so what to do? What to do? So I'll make use of alpha minus beta, alpha minus beta whole square, because we have the algebraic identities for squares. Okay, alpha plus beta square, or alpha minus beta square. So I'll express alpha minus beta square in terms of alpha and alpha plus beta and alpha into beta. Okay, so what I'll do, so this I'll express, it is nothing but a square, okay, plus b square minus 2 alpha beta. Correct? Correct. Now shall I convert this to be alpha plus beta whole square? Yes, by adding plus 4 alpha beta, but I can't add only I mean, if I'm adding any term to the one side, I also need to subtract minus 4 alpha beta. Okay, so this is going to be alpha square plus beta square, and this is going to be plus 2 alpha beta. Okay, and that minus 4 alpha beta as it is. So this is going to be a formula, alpha plus beta, okay, whole square. I mean, I have got sum of zeros. Let whole square you can get, but you should not get alpha square and beta square. Minus 4 alpha beta. Yes, product of zeros. Yes, now we will make use of this. So we will find okay, so here even I will substitute alpha minus beta, it is given 6. Okay, I'll substitute 36. Okay, so I'll write the equation. I'll shift 4 alpha beta to the left side. So 4 alpha beta, okay, is equal to alpha plus beta, it is given 12. Okay, 12 square, and 36 I will shift minus 36. So it is 12 square, it is 144. Correct? Minus 36. Okay, now I want only alpha beta. Subtract. So it is 14 minus 6, 8. Okay, and 3 minus 3 is 0. Okay, and it is 1. Divided by multiplication, bring other side division. So alpha into beta is equal to 4 2s are 8. Okay, 8 and 4 7s are 28. So product of zeros we are getting 28. Okay, so sum of zeros it is already given, and we have got product of zeros also. Now we will make use of the standard form of a polynomial. So what is that? It is k family. Okay, k can be some constant, x square minus alpha plus beta x plus alpha into beta. Okay, so we will substitute. Okay, k x square minus sum of zeros, which is already given, 12, x as it is, plus product of zeros, it is 27 equal to 0. So which is option? X square minus 12x plus 27. It is option B. Correct? Fine. So I have took equation, polynomial equation, but as for just a polynomial, no need to take equal to 0. Okay, so next one. Again, this is based on a graph. So here the graph of y equal to pix. Okay, so here this y equal to, okay, pix. It means this y is a function of x. It means you need to see the graph with respect to x. You need to observe the graph with respect to x. Okay, if it is y equal to, I mean x equal to p of y, then it would be different again. Okay, so as per the given question, you can see I can take 1 2 3 4 5 6. So we have got 6 graphs. Okay, so 6 functions of x we have plotted here. And the question is the polynomials having two zeros. So you need to understand two zeros means the graph should either touch or cut or intersect the x-axis. Okay, so with the first option you can see the graph is intersecting x at only one point. Second option you can see, yes, the graph is intersecting the x-axis at two distinct points. Again, third, so the graph not at all touching the x-axis, so no zeros. Okay, now here fourth option, so here again it is touching at 2 points, right? Don't see for y-axis, as y is function of x, you need to check with respect to only x-axis. Okay, this is okay, fine. Then here also you can see the graph is touching the x-axis, and here it is touching x-axis not only 2 points but more than 2 points, so this is not considered. Okay, so here you can see second, okay, fourth and fifth. Okay, so second, fourth, fifth, so it is option D. Option D is the correct answer. Okay, so this way we have solved some important MCQs of polynomials. So in the next class I'll start with the next chapter. Okay, so what we have done, we have actually selected algebra part. So we'll first try to complete algebra part. Okay, in the second unit algebra we have 4 chapters, and then we'll move on to the next one, I mean coordinate geometry and geometry unit. Okay, fine. So in this much, so we'll continue in the next class. Okay, keep supporting.